Hello students, so in the last video we have discussed about the D and F block elements. I hope you have understood it. I hope you have completed the notes of the D and F block elements plus the previously asked questions, some repeatedly asked questions I have given at the end of that video. I hope that you have written it in your notebook and studied it. Okay, so we are going to start our next chapter, solid state. Okay, it was not there in the previous academic year. That particular chapter was removed, but for this academic year they have again taken it. So this is the first chapter in chemistry, that is a solid state. So we'll be studying that now. Okay, you know something about the solid states. In last year we have discussed about the liquid states of matter. One chapter was the on that we have discussed about the gaseous state and the liquid state also. Now in this year we are going to study about the solid state. That's the first chapter in the chemistry. So we have skipped it because we thought that for this academic year also that chapter won't be there. But in the updated chemistry syllabus, that particular chapter, there are certain topics they have removed, but otherwise all the major topics are there for your board examination. So study well, see it, and at the end of this video I have given the notes of that chapter also. Solid state notes I have given at the end of this video. Write it down in your notebook and send me your notes when I am asking you to send it to my WhatsApp number. Okay.
We know that matter can exist in three different forms depending upon the force of attraction between their constituent particles, right? So what are these three states in which the matter is existing is gaseous state, liquid state and solid state. And in gaseous state and liquid state, the particles are held far apart from each other. So they can undergo translational motion, rotational motion and whatever that motion they need, right? So and they will occupy in the all the spaces that is given in a particular container. But in the solid state, the particles are held very tightly or very closely packed with each other. So in solid state, the particles cannot undergo any translational motion or rotational or any of those type of motions. But the solid state, the particles can undergo, it can vibrate from its own space, right? So solid state can vibrate. These particles can just have a vibrate by staying on its own position. Because of this closely packed nature of the particles in the solid state, they have definite properties also. Okay, so what are the main properties of the solids are? They have definite shape and volume. They have no ability to flow. They are incompressible and they are rigid also. So all the properties of these three states in which the matter is existing is depending upon the position in which the particles are staying. Gaseous state and liquid state, they are very far apart, and in the solid state they are very closely packed. In fact, we can say that these states in which the matter is existing is depending upon the external temperature and pressure also. For example,
at 1 atmospheric pressure, water in liquid state gets converted into its solid form, ice, at 0 degrees Celsius or 273 Kelvin. Let us now understand how the molecules of water in liquid state attain the molecular arrangement of water in solid state.
And the solid state are interconvertible with each other when we change its pressure and temperature. All the properties of the solid state are because of the constituent particles present in it. All the properties of the solid state will depend upon the nature of the constituent particles, the force of attraction between each other, and how closely they are arranged, or how thus the particles are arranged in its solid state. Okay, these all depends all the properties of the solid state. Generally, we can say that all the properties of the solid state are because of the structure of it. All the general characteristics of a solid state is depending upon the structure of that particular material. For example, if you are altering the structure of the silicon, we know that silicon is a conductor, so that conducting nature of the silicon can be increased if you are adding an impurity known as arsenic into it, right? So that structure is changed, so their conductivity also will get increased. So we can say that all the properties of the solid state is depending upon its structure. For example, these various things that we are using in our day science is using all these things, right? Intercalatin compounds, so we call it as the fullerenes. Then the ceramics that we are using, then the synthetic biopolymers, carbon nanotubes, these all are some of the materials that we are using in our scientific field, right? So these all are having certain uses and the properties because of its shape, or it because of its structure. So it's important that we should know about the structure of the solid. So in order to the application of the science and technological field, it is really important to know the structure of the solid state. Depending upon the arrangement of particles in the solid state, the solids are classified into two: crystalline solids and amorphous solids. What are crystalline solids? Okay, so crystalline solids, the particles are arranged in a perfectly ordered manner. The particles can be atoms, molecules, or ions. It will be arranged in a perfectly ordered manner in a three-dimensional manner. Such type of solids, we call it as the crystalline solids. Okay, so crystalline solids, the particles, the constituent particles are arranged in a perfectly ordered manner. Thus, a crystal is defined as the type of solids in they are having a definite geometrical shape. Crystals are having definite geometrical shape. The main examples of the crystalline solids are quartz and sodium chloride. These all are examples of the crystalline solids. Let us now discuss about the next type of solid, that is amorphous solids. Amorphous, that word is taken from a Greek word known as amorph, which means shapeless. So thus, amorphous solids are those solids in which the constituent particles are not arranged in a perfectly ordered manner. So it is randomly placed. So they don't have a definite geometry. We say that amorphous solids are short range order. It is of short range order. What does that mean is that there is an irregular arrangement of particles and it will be observed only over a short distance only. Amorphous solids are soft and they melt and start flowing at a particular temperature. It can be molded and can be blown into various shapes. So amorphous solids have the same structural features just like a liquid, but it has no regular shape. Most common example of the amorphous solids you can see at the ancient very old window panes and all. When you're looking at it, you can see that at the end of this window glasses, you can see it will be much more thicker than at the top. That is mainly because amorphous solids have a tendency to flow. Rather, it will be very slowly, but it has a tendency to flow. So, it is sometimes called as pseudo solids or supercooled solids. Pseudo solids or supercooled solids. Crystalline solids, on the other hand, it has a very sharp melting point, and when it reaches its melting point, it has a little changes into its liquid state. So it has more features same as that of the liquid state. So that is one of the difference between crystalline solids and amorphous solids. Crystalline solids will melt at a sharp and characteristic temperature, whereas amorphous solids it will gradually soften over a range of temperature. Another difference is that crystalline solids, as we have discussed, it has a very characteristic definite geometrical shape, whereas amorphous solids are having irregular shape. Crystalline solids are anisotropic in nature. Anisotropic. What does that mean is that it is having certain physical properties like electrical resistance or even the refractive index. They will have different values when measured along different directions. In different directions, when we are measuring these physical properties, they are showing different values. It is because of the regular arrangement of the particles in the crystalline solids. On the other hand, amorphous solids are isotropic in nature. Isotropic, that means it is having no same values when it is measured in different directions. It is because of the random arrangement of particles in the amorphous solids. Another major difference between crystalline solids and amorphous solids is that when we break the crystalline solids into pieces, the newly generated the surface will be plain and smooth only. Whereas if we are cutting amorphous solids into pieces, they will cut into pieces with irregular surfaces. Okay, then the heat of fusion also different for crystalline solids and amorphous solids. They have definite and characteristic enthalpy of fusion for the crystalline solids, whereas amorphous solids do not have definite enthalpy of fusion.
Now we are going to discuss about the classification of the crystalline solids. So the crystalline solids are classified into various types depending upon the nature of forces, the nature of intermolecular forces that held the particles close with each other. We know that in the crystalline solids there are a lot of particles are there. So these particles are held together by a particular intermolecular forces or bonds. So whichever of the forces or bonds that is holding these particles together, we have divided the crystalline solids into various types. So we have molecular solids. It is divided into molecular solids, ionic solids, metallic solids, and the fourth classification is covalent or network solids. So depending upon the intermolecular forces that exist between the particles of the crystalline solids, it is classified into molecular solids, ionic solids, metallic solids, and the covalent or network solids. Okay, so one by one we can study each of the types of the crystalline solids. So the first type of solids that we are going to discuss today is about the molecular solids. So molecular solid is the first type of classification of the crystalline solids. Okay, here the constituent particle of the molecular solids are the molecules. So here the molecules are the constituent particle. So these molecular solids are classified into three. So there are three main type of molecular solids. So the first type is non-polar molecular solid. Non-polar molecular solid. Then we have polar molecular solids. And hydrogen bonded molecular solids. Okay, so three main classification of the molecular solids are non-polar molecular solids, and we have polar molecular solids and the hydrogen bonded molecular solids. Okay, so again the first one that we are going to discuss here is the non-polar molecular solids. So non-polar molecular solids means from the name itself it is non-polar molecules. Non-polar molecules like H2 is a non-polar molecule. Then Cl2, then I2. So these non-polar molecular solids are formed by the non-polar molecules like H2, Cl2 and I2. Okay, these all are examples of the non-polar
crystalline solids or non-polar molecular solids. Here these molecules are held together by very weak dispersion phases. We have studied it in our solid state, right? Dispersion forces. In the last year we have studied about the non-polar molecules which are held together by the dispersion forces, or do you remember it? We call it as the Lenten forces. Here the force of attraction between the non-polar molecules are the dispersion forces or the Lenten forces. So what are the main characteristics of these solids? So these solids are soft. They are soft and they won't conduct electricity. They are non-conductors of electricity. They are non-conductors of electricity. Okay, the main characteristics of first one is they are soft, then they are non-conductors electricity, and they are normally at the room temperature and pressure. They are normally in its liquid state or in the gaseous state. They normally exist in the liquid state or the gaseous state. Okay, then what about their melting point? They have very low melting point. The melting point is very low. Okay, so these are the main characteristics of the non-polar molecular solids. So now we can look at the polar molecular solids. What are the main characteristics of the non-polar molecular solids? Sorry, polar molecular solids. Here the molecules are the polar molecules. Polar molecules, like which all are the polar molecules? For example, HCl. HCl is a polar molecule. Then SO2, etc. These all are the polar molecules. Okay, so polar molecules are the constituent particles in the polar molecular solids. So which is the force of attraction that is holding these things together? They are dipole interactions are there. So dipole force of attraction. Dipole both are polar molecules. So dipole force of attraction is holding these molecules together. Now what are the main characteristics of the polar molecular solids? They are just like the other one, they are soft. Then they are non-conductors of electricity. They won't conduct electricity. They are non-conductors of electricity. Then when we compare to the melting point is it is greater than the what else? Non-polar molecule. Okay, polar molecules melting point is low, but it is greater than those of the non-polar molecules. Okay, and still they are mostly existing in the gaseous state or the liquid state under the room temperature and pressure. Okay, then sometimes you can see the solid forms are also the solid. Mainly it will be in the form of gaseous or liquids, but there are solid SO2 is present. Solid SO2 is available. Then we have solid NH3 ammonia is also available. Okay, so it can even exist in the solid form, but normally at the normal conditions of temperature and pressure it is existing in the form of gaseous or the liquid state. Okay, now we can look at the next type of molecular solids, that is a hydrogen bonded molecular solids. Again, from the name itself we can see that the molecules which is having a hydrogen bonding in between. For example, the molecules which is forming between hydrogen and then most electronegative elements like fluorine, oxygen, nitrogen. These all are molecules are forming hydrogen bonding, right? Hydrogen with the fluorine, oxygen and nitrogen are forming hydrogen bonding with each other. So these molecules are bonded together by the hydrogen bonding. For example, water molecules are held together even in the form of ice. It can exist in the form of solid state ice. So these are bonded together by the hydrogen bonding. Okay, so hydrogen bonded molecular solids means the constant particles are held together by the hydrogen bonding. Now, what are the main characteristics of the hydrogen bonded molecular solids? Again, they are non-conductors. They are non-conductors of electricity, and they are volatile. They are volatile liquids, or it will be like soft solids. It will be, if it is a solid state, it will be very soft solids at the room temperature and pressure. They are volatile liquid. What is meant by volatile liquids? They are easily get evaporated when we changes the temperature. Okay, so these are the main three classification of the molecular solids. The first one is non-polar molecular solids, polar molecular solids, and the hydrogen bonded molecular solids, depending upon the force of attraction between each other. Non-polar molecules are like hydrogen, chlorine, iodine, non-polar molecules. So the force of attraction between each other is dispersion forces or the London forces. For the polar molecule, the force of attraction is dipole-dipole force of attraction. For the hydrogen bonding, the force of attraction between each other is a hydrogen bonding itself. Now its main characteristics also. Okay. So we have discussed about the molecular solids. So the next type of solids that we are going to study is about the ionic solids. The second type of crystalline solids is the ionic solids. As the name indicates, ions are the constituent particles present in the ionic solids. So these solids are formed by the three-dimensional arrangement of the cations and anions. Okay, ionic solids, the constant particles are ions itself. It is formed by the three-dimensional arrangement of cations and anions. And since it is a positive and negatively charged particle, what is the force of attraction between each other? It will be the electrostatic force. Electrostatic force that is existing between the oppositely charged particles, right? Or we call it as a Coulombic forces. We call it as a Coulombic forces. So electrostatic forces or the Coulombic forces is existing between the particles of the ionic solids. Okay, now what are the main characteristics of these solids are? The first one is they are hard. They are not soft, they are hard. And they are brittle also. They are hard and brittle in nature. They have high melting point and boiling point. Okay, they have high melting point and boiling point. Then, since the force of attraction between the ionic solids are very strong, electrostatic force or the Coulombic force, we know that oppositely charged particles, so they are very strongly held together. So the ions are not free to move, right? Ions are not free to move. So what will happen over here? If the ions are not moving, they cannot conduct electricity also. So they are insulators. So they are insulators because the ions are not free to move. But in its molten state, that is when it is dissolved in the water, in molten state, or if it is dissolved in water, what will happen means the ions can be present over there. So ions will be free to move and they will conduct electricity also. So here in this case it will conduct electricity. Okay, so these are the ionic solids. Ionic solids, the constituent particles are ions. So it is a three-dimensional network in which the cations and anions are present over there, and it is held together by a very strong electrostatic force or Coulombic forces. Since that force is very strong, the ions are not free to move, so they are insulators. But in molten state, or if it is dissolved in the water, they can conduct electricity. Then they are hard and brittle and they have high melting point and the boiling point also. So the next thing that we are going to discuss is the metallic solid. So we can see what is meant by metallic solid and the covalent solids are.
Metallic solids. The most common examples of the metallic solids are like copper, iron, silver and magnesium. So in the metallic solids, a collection of positive ions are surrounded by or held together by a sea of free electrons. Hence, the constituent particles of a metallic solids are positive ions in a sea of free electrons. Metallic bonding is arising because of the electrostatic force of attraction between the positive ions and the negative ions. These electrons are delocalized over the entire system. Thus, free and mobile electrons are responsible for the high electrical and thermal conductivity of the metals. So when an electric field is applied, these electrons flow through the network of positive ions. And When a heat is applied to one portion of this metal, the thermal energy is uniformly spread out throughout by the free electrons present in it. Another important characteristics of these metals are they are lectured and they are colored in many manner. And this is also because of the presence of free electrons in them. Metals are highly malleable and they are ductile also. Next type of crystalline solid is the covalent or network solids. The main constituent particle of the covalent solid is the atoms itself. These atoms are bonded together by the covalent bonding. And this covalent bonding will be present throughout the crystals also. These covalent bonds are also known as covalent solids are also known as the giant molecules. The common examples of the covalent solids are diamond, graphite, and even quartz. These solids are very hard and they are brittle also. They have high melting point. They are insulators and they do not conduct electricity also. For example, diamonds and silicon carbide. Covalent bonds in this solids is very strong and it is directional in nature. Therefore, atoms are held very strongly at their positions. Diamond. Diamond is an example, it is a typical example for such solids. They have a melting point around 3550 degrees Celsius. But graphite, although graphite is also belonging to this type of crystal, but it is very soft and is a conductor of electricity. The exceptional properties of the graphite is because of its structure. The carbon atoms are arranged in different layers and each atom is covalently bonded to the other three atoms in the same layer. And the fourth valence electron of each atom is present between different layers and are free to move about also. And these layers are bonded together by the weak van der Waals forces. So there is a free electrons over there in the graphite, which makes the graphite as a good conductor of electricity. And different layers are there for the graphite which can slide from one over the another. This makes the graphite a soft solid and is a very good solid lubricant also. So each carbonate atom is bonded to the other three carbon atoms and there is an extra free electrons over there. That free electron is it is free to move also. So that movement of free electrons results in the conduction of electricity.